Welcome to this video created in partnership with Grey Matter on the Intel Distribution of OpenVINO. My name is Stephen Blair-Chappell from Bayncore, an Intel OneAPI technology partner that provides training, consultancy and technical support in HPC and AI. This is the last of 8 short videos. You'll remember from our previous videos that there are 7 toolkits. And in this video we're looking at the Intel Distribution of OpenVINO toolkit. The OpenVINO name stands for Open Visual Inference and Neural Network Optimization and has a mixture of libraries and tools that you can use to optimize and deploy inference applications. Before we go any further, let's remind ourselves about the difference between training and inference. In a training and inference workflow, you would first develop and train a model on a compute facility. This could be quite compute intensive and take days or weeks to achieve. In our example here, we are training a model to recognize objects for a traffic monitoring application by offering multiple labeled images, for example images of people, cars, roadside furniture, etc. Once the model has been trained, you then deploy the trained model on an edge device. It is in this second stage that OpenVINO is used. You would never use OpenVINO in the training phase, but only in the inference phase. In our example, the application is used to detect a person walking next to the railway line. In many inference applications, the model evaluation needs to be in real time, so appropriate responses can be made by the host system. You can use the optimization features of OpenVINO to improve the real-time response of the inferencing. OpenVINO can optimize trained models from different frameworks and deploy the model onto different kinds of Intel devices. There are 3 steps in using OpenVINO. The first step is to acquire your trained model from your training environment. The second step is you optimize the trained model using the OpenVINO Model Optimizer. The output of the optimizer is known as the OpenVINO Intermediate Representation and is held in a pair of files that describe the network topology and contains the weights and biases of the model. The third step, you use the inference engine to deploy the optimized model and output the results. The OpenVINO toolkit has a number of key components. This page shows the contents of the Windows installation. A similar list of components is also available for the Linux and macOS installations. The Model Optimizer imports, converts and optimizes models into a format usable by the OpenVINO inference engine. Popular frameworks supported include Caffe, TensorFlow, MXNet, Onyx and Caldi. The inference engine runs the deep learning model. Alongside the inference engine is a set of libraries so you can easily integrate the inference into your applications. Included in the kit is the well-known OpenCV computer vision library. The version here is compiled for Intel hardware. The kit provides a collection of code samples and demo applications written in Python and C. Additional tools are provided including an accuracy checker, a post-training optimization tool and a model downloader. A large collection of pre-trained models are available via the Open Model Zoo repository. Alongside the OpenVINO toolkit comes a deep learning workbench which can be used to drive all the stages of your inference work. The quickest way to experience OpenVINO is to register for the Intel Dev Cloud. Note that there are 3 Dev Cloud platforms offered, one for FPGA devices, another for edge devices, and a third one for OneAPI applications. For the work with OpenVINO, you should select the Edge Dev Cloud. Once on the landing page for the Dev Cloud, choose the Build tab and begin to explore some of the examples on offer. So this was the last of 8 videos. I hope you found those interesting and useful. Alongside these videos there are 3 labs of a longer duration which are welcome to experiment with.